Hello friends, welcome to BISP Solutions. Myself Ashwin and I work as a technical consultant at BISP Solutions. BISP Solutions is a tech company and provide technological solutions across the world. Now in this video I am going to show you about tensors. This is an introductory video on tensors. So it is related to PyTorch, right? So what are tensors? A tensor is a multidimensional array. See, in our programming language, whatever we call array, the same thing is called as tensor in PyTorch, right? Okay, in PyTorch, tensors are the primary data structures used to storing manipulating numerical data. Numerical data, whatever we are having, we manipulate them with the help of tensors. Now, tensors are similar to NumPy arrays, but with additional capabilities. Unlike NumPy, tensors can be used on GPUs to accelerate computing by performance parallel processing. Now see, we will go in depth step by step, right? Tensor supports automatic differentiation. Now what is this? I will prepare a separate video on it. Today just have a look on tensors. This is an introduction video. So what are tensors? Tensor types of tensors. Now see tensor type. Zero dimensional tensor where x equal to 5, that is called zero dimension. Vector one dimensional tensor. So v equal to 357, that is called one dimensional, and 2D tensor means where two rows are there. Multi-dimensional means three dimensional, four dimensional, n number of, right? So now let's do some practical. Now what I will do here, I will create a new interactive Python notebook. Now what happened here? So first of all, I will show you a simple tensor, right? Simple tensor. Now see here, I have imported the torch data equal to 1 comma 2 3 comma 4, and this way torch dot tensor equal to, this is called 1 2 3 4, right? So it's a one dimensional tensor. Now we will see here a random tensor. Now see what is the random command. Now look at this. This is called random x underscore rand, torch dot rand. So 3 by 4. So 3 by 4 means 3 rows and 4 columns, right? So 3 by 4 tensor with random numbers. Okay. Now look at this. Every time the number is changing, right? Every time the number is changing. So in this way, this is called 3 by 4 tensor, which is using the random command. So next is zeros and ones, right? X underscore s. 2 by 3 matrix of zeros and 2 by 3 matrix of ones. So look at this, 2 by 3. Okay. Suppose if I make here x underscore z. Okay. Look at this. So this is called zeros and ones tensor. Now tensor for a float number. Look at this. Float number tensor 1 point, 2 point, 3 point, right? So here we have given data type is float, right? Another is, now I'm going to add addition of two tensors. Now see here, 1 and 3, 2 and 4. We are directly adding these, right? It's very simple, the addition. Now let me show you about the multiplication of tensors, right? So the multiplication of tensor is also quite easy. Now look at this, 1 multiplied by 3 and 2 multiplied by 4, right? This is one dimensional tensor, okay? So the multiplication of one dimensional tensor. Now let me show you one more thing. Now look at this. Now how it happened? Now see here, just imagine it like this: 1 comma 2 and 3 comma 4. This is one tensor and this is another tensor. Let's do this. Just imagine about the array 7 comma 8. Now 1 multiplied by 5 plus 2 multiplied by 7. 5 plus 7, 14. 5 plus 14, that is 19. Similarly, 1 multiplied by 6 and 2 multiplied by 8. 16 plus 6, that is 22. So this thing you might have done in your 12th class, right? In 12th standard, this matrix multiplication in trigonometry, this is very similar to trigonometry. Okay, so now let's see this also. One more example. Now see here, we are reshaping. What we are reshaping? For example, if I put here A, now see A means 4 by 4 array, right? And we are transforming it into 2 by 8. So we are transforming the array. That is called reshaping the array. Okay, now to enable gradient tracking for a tensor use. Now this type of example I will explain you in a separate example, right? For this to understand this right now, just understand that x torch dot tensor require gradient equal to true, required gradient equal to true. Right now there is nothing special done here, but when a proper example, I will create another video with a proper example here, right? So in this way, guys, this was all about the tensor. This is an introductory video on tensor, and I recommend you to watch it once more so that it will be clear to you. And those who are new in this channel, please like and subscribe to the channel. Next, in our next video, we will see some other topics, right? Thank you, guys. Thanks for watching the video.